Hello and welcome to Wearable Electronics with Becky Stern.
Hey everybody, it's July 8th. With me is Jessica Califano, Director of Community Support and Publishing here at Adafruit. We're going to talk to you today about some wearable electronics. Big surprise. Jess, what's on today's show?
So, today, Wearable Wednesday on the blog.
We're going to debut a new Teardown video.
Component of the week.
What could it be? It's so small and contains so few parts.
Material spotlight.
Don't you like wire?
Wire.
It's my favorite thing.
Questions and answers with Becky.
Yes, so if you have any questions about wearable electronics, you can ask them in the comments of the live show here, YouTube comments around the Adafruit channel, the Google Plus page, and on the Adafruit blog or Twitter, and we'll gather them up and answer them on a future show, making you eligible to win this show's giveaway.
Which is Getting Started with Electronics, or Getting Started with Adafruit Flora.
By me and Tyler Cooper.
Yes.
You want the book, you ask a question. You get your question answered, maybe you win a book. That's how it works.
That is it.
Our code today is MUSE.
Muse.
We'll find out more about that why in a second. But you can use it to get 10% off your whole Adafruit order, everything except gift certificates and software, until the midnight tonight, 11:59 p.m.
11:59. Okay, so let's talk Wearable Wednesday on
What
the
do we
blog.
do on the blog every Wednesday, Jess?
We blog about wearables. With Leslie posts a bunch of posts, I post, Becky posts, and we talk about your wearables projects, stuff that people post in the forums, customer projects.
Yeah, and cool news. So if you have a cool wearables project, you want to send it in so that we can put it on the blog. Just a few of our favorite projects from the blog this week. This is a beacon shirt. Leslie posted this up. It's got NeoPixel LEDs, a bunch of them on a t-shirt substrate, many, and it's visualizing.
So many. Lots.
It's visualizing local wireless information. So like Bluetooth and Wi-Fi devices is supposed to, like make visible the invisible. And so they took it to like an ice skating rink and had some nice activity going on because of everyone's phones. It's like a neat awareness project. I don't like why a t-shirt. I don't know. Like I think this pattern would look really good on a handbag.
Yeah, it would be cool on a handbag too, or backpack.
But that's a lot of LEDs to power, but if they're not all on all at once, like this, or just selectively on, then you don't really need as big of a battery pack if you never intend to have them all on. But I guess each one of those animations is to visualize a different device or and running on a different protocol. So cool ambient awareness. Maybe you bring it to your one of those like encryption meetings or like secret technology meetups where you're not supposed to have your cell phone on and like no one would know you were wearing it unless somebody in the room is like violating I don't actually know what parties where you're not allowed to have your phone on like that, but
Maybe at the White House.
yeah, maybe. Right? Obama could wear this beacon shirt. Really cool. Anyway, next up, another favorite project from the blog this week. This is a skirt with some like undercarriage lighting. So like inspired by some Japanese pop artists with these big tutus. I don't remember the name of their band, one of these like multi-girl bands. They each have their own colored tutu. This lovely maker wrote in to show us her mini skirt with undercarriage LEDs. It's really neat actually. If you look at the image sequence, she covers like 3D modeling the enclosure for the battery and the Bluetooth module, which is like similar to the Bluefruit and has an iOS and Android app, and then a strip of NeoPixel sewing them into the bottom of the skirt. You can change the colors from your
Cool. You
phone.
can match your shirt. Or
like if you're at a rave or whatever, you can match it to the lights that are happening in.
that would be cool. Raves. I don't know. I've never been to a rave.
Yeah, no, me neither. But don't tell them. We've been to and can cater to the needs of many ravers.
Yes. we sit at Becky's desk and rave with wearables.
I make a lot of like raving costumes. I mean, a lot of costumes that would be like appropriate for ravers. Although she points out that a lot of them don't have big enough batteries and for like partying all night, and that is true. If you want your garment to last all night, you need to put a big beefy battery. So
I think I would need a big battery to power myself through a rave.
yeah, especially if you were going to one with all those wireless devices everywhere.
Okay, next up.
You posted this one. What is this?
Yeah, it's a running vest with blinking LEDs that blink out Morse code. I don't know Morse code, so I don't know what this says, but...
He didn't include that in his write-up?
No, it wasn't included.
Secret messages.
It's probably something like, watch out, I'm running.
I think that's probably exactly what it is.
Right.
If you guys, if anybody goes over to the blog and watches the video and tells us what the Morse code on the vest means, we'll give you a sticker. You'll have our eternal gratitude. This is used a Gemma and some NeoPixel strip. You can see some very excellent heat shrink technique going on here to protect the junctions in the NeoPixel strip, both for durability and weather or sweat resistance, I'd imagine. So that's super cool video you can also find on the blog.
Next up, Teardown.
Yeah, Dave Jones took apart from EEV blog, which you guys might be fans of, took apart the Pebble Time, the new Pebble watch. So that's nice. Thanks, Dave, like taking things apart so we don't have to. I love it when someone else does a very complicated wearables teardown that we can then just link to. Just because the simple ones give me more satisfaction. I like the weirder ones. This is very like mainstream, or very popular. The Pebble Watch being one of the most popular Kickstarter projects of all time. He got his Kickstarter backer reward watch. He took it to some crazy outdoorsy kind of
he rolled around in the mud with it.
Some kind of durability test, and it still worked. And so he was like, well, okay, fine, then I'm just going to take it apart. And so you can see all of the cool flex connectors. I love these complicated wearables, the way they package stuff inside the enclosure. That's always really interesting to see them take advantage of all that real estate and make the PCBs a funny shape. And to see where they put the battery, if there's wireless, where the antenna goes. Like, it's all a very complicated circuit pie, or not even a sandwich anymore. It's like too many layers.
Yeah.
It's like a Jello, patriotic Jello dessert with layers of different colored
chunks of little fruit inside,
and then a whipped cream layer, and then
gross.
Can you tell I'm hungry? Speaking of teardowns, this week's wearables video debut is a teardown. We do once a month or so. Lady Ada comes over to my desk and we take apart something cool and talk about the chips on the board, reverse engineer the design of the circuit. We learn about their business practices sometimes with their where they got their parts and why they might have made certain decisions. And in this case, the Muse headset is for meditation, and it has some really interesting material properties to it, as well as some cool chips inside and some surprises. So without repeating my recorded self too much, why don't we just watch the video and you guys can find out more about it. Welcome to another wearables teardown here at Adafruit. Today we're looking inside the Muse, a brainwave sensing headband for assisted meditation. It pairs over Bluetooth with your phone to guide you through a meditation session with real-time feedback on your brain's activity, followed by some stat tracking that helps you improve your calm over time. There's some interesting hardware going on inside this device, so let's see what Lady Ada has to say about the design of the circuit.
Thanks, Becky, for taking it apart. We've got two circuit boards in here that we've pried out of sort of the ear area. And here's a micro USB connector. We've got, probably a polarity protection diode here. This is probably the charger for the battery because it's right here next to the BAT- and BAT+ connector. Given all of these resistors and capacitors here, and it says test point, and the fact that they probably do have to test the electrodes, makes you think that this is probably an op-amp of some sort, either a single or dual op-amp, and it's amplifying the signals or buffering the signals somehow so that these can be tested during assembly and manufacture. And then we've also got, a date code and Muse, that's kind of nice. And then on the back, alongside with the battery, there's this connector. And this is for that flex circuit that goes around the headband. Here is the other circuit board. So this goes on the other ear area. So let's check this out. On this side, we have another micro USB connector. There's one on either side. This one is definitely connected to this chip, which is a PIC24. So this is a PIC microcontroller. This is probably doing all of the USB and calculation for all the sensing technology here. On the side here is going to look accelerometer. Accelerometers always have this kind of chunky look. This is an MMA 8543 or similar family, low cost triple axis accelerometer. You got a lot of test points here, probably for programming. Over here, it looks like there's either some sort of buck or boost converter. There's an inductor or something, a little chip, and then a switch which you can use to set it between modes. And then here's where we get to the really interesting stuff. So there's like a lot of resistors and capacitors here. And this really lets us know there's definitely analog stuff going on because there's just so many resistors and capacitors, way more than just that you would need for power filtering. And you can look up these two components. We've got the OPA 4374. That's a quad rail-to-rail CMOS op-amp. And then the littler chip over here is an MCP 6L02. So these are both precision op-amps. This is the analog part that takes the sensing from your noggin and amplifies that signal and sends it into this microcontroller that does the actual digital signal processing. So let's flip over. On this side, we also have another flex connector. There's some diodes here. That's good for signal level protection. And then here I've got a big module. So this is kind of interesting. And we'll peel this off carefully to reveal the RN42. The RN42 is from Roving Networks, which is now owned by Microchip. And it's a Bluetooth Classic module, which is very interesting because all the wearables that we've looked at so far are Bluetooth Low Energy. Which is kind of interesting because if you are not using Bluetooth Low Energy here, using Bluetooth Classic, then how are they using it with Apple devices? Because you need that certification. And so when I was looking up this chip, and I was realizing I couldn't figure out what this chip was. And that's when it hit me. This is that made for iPod or made for iOS authorization chip. And this is the MFI, made for iPod, 3373959. And this is the authentication chip that this module used to let it talk to iOS. This must have been designed quite a few years ago before Bluetooth Low Energy became popular, because if this was made now, they would definitely go with BLE. Bluetooth Low Energy is one of the few wireless protocols that iOS, Apple, and Android both support, and you don't have to go through any sort of like made for iPod or certification process. And it'll be a lot cheaper and a lot easier for them not to need to use the RN42 and this like annoying expensive chip that you have to buy only from Apple. Both of these have a little snap connector on the side, and they plug into these two pieces here. I removed this hot glue. This flex circuit connects the two pieces, so the battery can power the circuit on the other side. So that's good for space. You have two equal lumps on either side of the ear. But this is also used as a sensor. They actually just used the circuit itself, the flex circuit itself, and played it with what looks like silver, which makes sense, it's hygienic, and then plug that into the two circuits on either side. So this flex circuit not only is used for power and signal, but is also the sensor itself. You got 3 reference sensors in the front, and then 2 more sensors on the side for tempo measurements. But they also need to get some measurements from sort of behind your ear. So these parts are actually conductive rubber. And they're not going to be conductive enough to light up an LED, but they're conductive enough to just get that signal from behind your ear into the circuit board. And how they do that is really interesting. So let's look on the microscope. So here we've got this flexible conductive rubber, and this is bonded, connected right up to this metal piece here, which is used as sort of also part of the electrode. And then this metal piece comes out to this part of the enclosure, and on the circuit board itself, on each one, we've got this little clip. And then when this is put together, it presses up against the metal part, which presses up against the conductive rubber, which also feels really nice, but is also usable as an electrode. It's a really interesting wearable, and I'm going to go meditate.
For this and many other teardowns, we use the Adafruit USB microscope and its articulated stand. What wearable device should we take apart next? Let us know in the comments, and you can catch up on all our previous teardowns in the Teardowns playlist. Thanks so much for watching, and don't forget to subscribe to catch the latest videos from Adafruit.
So that was cool. I really want to try out one of those.
Well, here you go. It doesn't quite have the electronics in it anymore.
It doesn't have electronics
but it looks good on you. I think we could probably put it back together. It has, we just unplugged the flex connector. So that's always a fun thing. We never, when we do these teardowns, we never assume that we're going to be able to put it back together. And in a lot of cases, things are glued shut or glued to each other because there's a small space that you can't really use mechanical connectors. But these have the flex circuit just plugs into the PCB, and like, I don't know, I didn't like puncture the battery or anything either. So like, I'll try to put it back together.
Yeah, we should try.
I wanted to use their upgraded app. The Android app I found to be a little bit frustrating because the simulation is like a windy beach, and like the beach just stresses me out in general. It's just like sandy, and I have to reapply so much SPF, and like, so I would prefer, like, the website makes it seem like the new version of the iOS app has like more simulations, like a forest or something. When Leslie came to visit, and you saw Leslie modeling in the video, she's in the chat. Say hi to Leslie in the chat, guys. I was like, Leslie, this thing makes me infuriated. I need you to model it for me. And because I took it home, like, and we got this thing in like December, and we haven't like done the teardown until now because like I couldn't get some B-roll of me like doing it awesome. I would like do it, and then
wow, you're really stressed out.
I'm really
This beach is like having a thunderstorm right now.
I'm just like, I wouldn't say that I'm like stressed. I'm just like have a very active mind and I'm not trained in meditation. So Leslie is. It's just she put the thing on and she ran it, and like her session was like super calm the whole time. She's like, I heard a bird. There was sound in this simulation. I didn't hear any waves crashing or wind at the beach. It's like, well, it's good when you find something that you can practice.
Well, that's
at.
what it's for. You practice, right?
Yeah, exactly. Yeah, and you train.
Get better and better.
And it motivates you to train more because it like gamifies it a little. It gives you like, you got a reward for like calmest session yet.
Yeah, that's cool.
I'm excited about how calm I was. Anyway, the device itself is really cool. Muse has posted in our jobs board before looking for like a developer advocate. So it's obvious that they're planning to, like try to get more people to use their SDK and API, and make some new apps that use the device.
Yeah.
The device itself is super cool and very well made and like comfortable to wear and neat. So looking forward to seeing where that goes.
Awesome.
If you would like to purchase whatever we used to take apart the Muse, you can get 10% off like your USB microscope with code MUSE.
Muse.
Everything except software and gift certificates.
Okay, component of the week. Becky, what is this thing?
It's
what is this little guy?
New component. It's the JST SOTAP adapter, and it's for, I have also the sample in my hand. Ooh, it's meta, right? It's for joining like components that are more apt for soldering to components that are more apt for sewing. So say you're making like your, for example, the project that this would have come in handy for is the Cortana cosplay costume, the like Spanx with the NeoPixels sewn in, and it had like standalone sewn NeoPixels, and then attaching a NeoPixel ring is part of the same NeoPixel chain. And in order to connect to the rings have these like small holes on them that are close to components, and it's not really that easy to sew them with conductor thread. So we recommend soldering wires onto them, but then if you want to like connect it to your sewn circuit, you have to strip the ends of the wires, coil the leads of the wires, and sew through it, and it can pull, and it's like, then you can't remove the NeoPixel ring at all. So say you wanted to swap your microcontroller for a soldered one, or put in a soldered component that on your already sewn circuit, you could plop this thing in. It keeps the heat away from your fabric by you sew to it, then you solder the wires that it comes with to the NeoPixel ring or whatever, and then you plug it in. So it just allows for like a modular design. Say you want to add on to an existing wearables project. This is a good thing to have in your toolbox. It has a 3-pin JST connector. It's a tiny little thing you can see on the scale, and it comes with the 3-pin JST wire.
Right.
So it's just like a little grab bag, useful accessory. And I don't know how much it is. It's not very much. It's a couple bucks, and you can pick it up in the store with our discount code today and get 10% off. So you could get just order a couple of them if you're working on, if you plan on like tinkering with lots of wearables projects. It's a really good thing to have in your toolbox. And I would have used it. I'll make more.
Yeah, I'm sure that will be used
Video
in a lot
game.
of upcoming
Cosplay projects and stuff.
Yeah.
So like if you wanted to go from like a headdress to a monocle.
Ooh, NeoPixel ring monocle. That'd be cool.
As if we haven't done enough NeoPixel eyewear projects, NeoPixel ring eyewear projects.
Yeah.
This one, it's like the goggles, but it's only one eye, so it is a monocle. New project.
Hey, why not?
Maybe
Like steampunk thing.
Sure.
Yeah.
Steampunk over yet? Not hardly, right?
I don't know. I'm not big. I'm not
Yeah, I
in the
don't-
scene,
I
but
don't know. You tell
I'm
us.
sure there's still people.
There's
doing
still,
it.
I think, a monocle. I'm just gonna make one for myself.
Yeah.
Cool. Well, if you want to buy one of these or a couple, you can use code MUSE and get 10% off anything in the store except gift certificates and software until 11:59 p.m. tonight.
Okay, mysterious
material spotlight.
material spotlight. What are these things? They're pretty. Colors, rainbow.
Yeah, wire. You like
Wire.
wire. Everybody, you like wire. I like wire. Everyone likes wire. This is some 26 gauge silicone coated stranded wire, which you might recognize from the shop already, but we used to have it, or we still have it, in these smaller quantities, and now we have it in 25-foot spools. So if you've bought this stuff from us, and I certainly have had this experience, you pull it out of the bag, and the silicone sheathing is like so springy that like it kind of, the whole little spool just goes like bling.
It's like one of those like snakes in the can.
A little bit snake in the can,
Yeah.
and so it's hard to keep it organized. And we were selling it in these little bits, and we still are. But now we also have it in the 25-foot spool. So if you're like me and you use a lot of this stuff, you want to do long runs of NeoPixels, you can get the 25-foot spool. I imagine we'll have another gauge available soon, but we have right for now the 26 gauge in 5 colors: red, blue, yellow, green, orange, and 3. What do you call these? Neutrals: gray, white, and black. So match your skirt project, match your pants to your wire,
Right.
and you can use a lot of it. I know I'm going to go fetch some of these and put them on my wire rack like right after this. This is what the you can still of course get the smaller quantity in 26 gauge or 30 gauge in all the colors. So
It's useful.
if you want to get a discount on your wire and you want to stock up, you can use code MUSE and get 10% off all of your silicone coated stranded wire. It's really nice because it's heat resistant and high voltage and just the best stuff for wearables that we've experienced.
Okay, time for questions and answers. What is this week's prize?
A book.
A book.
Did you know how to get started with Flora? Because if you didn't, then you could get this. You could win this book, and then. And no, Tyler Cooper and I wrote this book, Getting Started with Adafruit Flora. It contains like a lot of cool classic Adafruit wearables tutorials, and then also all of the information you need to like set up your Flora environment. I
Great read.
hope one of you enjoys.
Yeah. Okay, let's see the first question here from Hazy T. I want to make an ugly Christmas sweater this year with Flora RGB NeoPixels and program in effects. I've used the rings in several projects, but this would be my first time sewing the individual pixels. Is there a technique for hiding the PCB so my sweater isn't covered by a dozen half-inch black dots? Am I looking at a trade-off between the versatility of the NeoPixel versus the smaller LED sequins? Thanks.
Nice question. Thank you very much. I would say that, like, yes, the sequins are smaller. They're also less bright, and they're a little bit harder to sew over a large area. The NeoPixels, because you can sew them in as line because they have a data bus, whereas the sequins have to be like all in parallel, and you can turn them all on and off. But for the size of the PCB, I don't think they're really that different. The LEDs are a much different brightness. But if you are making an ugly sweater, why do you care if it has black dots on it, first of all? Can't you just use a black sweater? But joking aside, you can just put them on the inside of your sweater. They're gonna shine through it. Like, I promise.
They're bright.
Unless it's like a parka with like down insulation in the middle. If it's just a sweater, one layer of knit fabric, NeoPixels will shine through it. So I would put it on the inside. That's my suggestion.
Yep. Okay. Next question is from Lisa Mather. I'm trying to sew 100 NeoPixels into my prom dress. Is it possible to use one Flora, or would you recommend I use 2?
I'm assuming this is a memory question, like how many NeoPixels does it have space for on the chip to drive? And Flora has a 32U4 microcontroller and has a lot of RAM. So you can, if you power them correctly, you can run up to like 500 NeoPixels on one Flora. It depends on what your animations are doing. If you have very complicated code space intensive animations, then maybe you can initialize fewer NeoPixels. It's all about how much RAM you have. So yeah, you're fine with 100, I would imagine, on your Flora, on your one Flora. And then we went back and forth on Twitter a little bit. I would use wire. Like, yes, you're sewing them because you're going to sew the NeoPixel chain into your prom dress, but I would not recommend using conductive thread for anything over 20, 25 NeoPixels.
Yeah, it'll be easier with wire, I think.
You'll have a much better troubleshooting time. and it'll be faster too.
Yeah. And send us pictures of your prom dress because I want to see it. I love looking at cool, like handmade, unique prom dresses.
Yep, and if you send it to us, we'd love to post it on the
We'll
site.
blog it,
This looks
yeah.
like it was a mom retweeting her daughter's private tweet. That's why I included it the way I did.
Cool. Next question. Hi, Becky. Can the Flora Bluefruit LE use the HID keyboard profile to relay keyboard input to the computer instead of just sending keyboard input from the computer? Also, can the Flora do capacitive touch input?
Yes, in fact, the HID keyboard profile for the Flora BLE module and our other BLE modules in the shop, they do in fact function as a keyboard for the computer to input keyboard strokes into the computer, not the other way around. So it doesn't do both,
Right.
but it doesn't do the one you assumed it did.
Yeah.
How could I answer that question any more confusingly?
Opposite day.
Opposite day. So what's interesting is the Flora itself, the Atmega 32U4, can function as a keyboard just by plugging it in. You can see that in our Nintendo controller project, where you just plug it in over USB and you program in the sketch, like, okay, when I press this button, send like a letter A. And you can do that same thing with the Bluetooth module and use it as a Bluetooth keyboard into the computer. The profile, I don't think, supports the other way around.
Right.
But you tell me. I've only done one project with the Flora BLE module. And then, yes, the Flora can do capacitive touch sensing, and we have a tutorial for it on the learning system. Just type in like Flora capacitive, and you'll see it up there. For sure. Absolutely. And that's a really fun thing to do with Flora in general, is to use conductive fabric and make touch sensors for keyboard input. So the plush Nintendo controller project and then the standalone capacitive touch tutorial both cover that.
Cool.
Good luck.
From Brian Bacardi. Colin, I got all your Sesame Street references. Can you recommend a good sewing machine for a makerspace?
Oh, sure. I don't know if there's any one particular sewing machine I would recommend for like above all others or anything, and we're certainly not affiliated with any sewing machine brands. My sewing machine is a Singer. What I would recommend when you're shopping is look for something that's like not the absolute cheapest one, and like something like middle of the line, and from like a brand with a good warranty policy in case one of your Hackerspace members like breaks it or something. And you're looking for something that's not too weird, something that's
something user friendly if like you're going to be
standard.
having it.
Yeah, like straight
a lot
stitch.
of people using it, you know.
Yeah, like you don't need a lot of features. Straight stitch and zigzag stitch is all you really need. Anything else is bonus. It should just be like easy to learn how to use by reading the manual or knowing how other machines work.
Yeah, read the online reviews, I guess.
Yeah. But like Singer's fine, Bernina's great. Like there's all kinds of whatever you can get your hands on. But I would say like not the absolute cheapest. Go for like middle of the road or like high end if you can afford it, because it'll make the machine last longer and put up with more abuse. I would say don't adopt a retired industrial machine. Industrial machines go way too fast for beginners, and they're meant for sewing for like expert seamstresses to pump out garments.
Right.
And they're like I even am intimidated by them and not really great at using them. So definitely like a good quilting machine, something that you get at like Joann Fabrics or read the online reviews. I hope that's helpful.
So this week's prize, getting started with Adafruit Flora. Let's see who the winner is.
Jess will choose the winner from the Stucky Burn hat. I know it. Well, I only fold it to provide some suspense.
It is Orpheus. The question about the Flora capacitive touch.
And Bluefruit HID keyboard. Cool. Congratulations.
So email support@adafruit.com. We'll send out the book to you.
If you didn't win, you can still join in on the party and get 10% off your whole order by using code MUSE. That's good until 11:59 p.m. tonight. That's our show tonight. Jess, it was jam-packed. Thank you so much for joining me.
Yeah, thank you for having me again.
Jess will be back again in, 2 weeks or something.
Yeah.
We did the schedule ahead of time this time. If you haven't subscribed to the Adafruit YouTube channel, you should do so that you can be alerted in the way of your preference to the launching of new Adafruit videos and also when our live streams go live.
Right.
Speaking of which,
tonight we have Show and Tell at 7:30 and Ask an Engineer at 8.
with Mr. and Mrs. Lady Ada, and you can show off your own project by commenting on the Google Plus event for the Show and Tell. Get added to the circle, then you'll be invited every week. Join the trusted crew of project showers and tellers.
Yep, and the Ask an Engineer is on at 8 on YouTube and Ustream. So be sure to check that out. Tomorrow, 3D Thursday Hangout with Noe and Pedro.
My favorite show. I mean, don't get me wrong, I like Phil and Lamore and all, but like Noe and Pedro be talking about some crazy,
They do some really cool projects.
really crazy 3D printing and electronics mashup combo projects, cosplay. They just are always having so much fun.
The chess set that they built is
oh my gosh,
incredible. So cool.
So if you are curious about 3D printing, make sure to watch that broadcast tomorrow, and then also stay tuned on the blog for 3D Thursday.
3D Thursday on the
posts
blog all day
long.
yesterday or tomorrow.
Thank you guys so much for watching. We'll be back. I think Phil's back again next week, and so you can hear all about his Apple Watch some more. And we'll see you later. Thank you.
Bye.